Hello everyone, welcome to the channel. In this video, we will learn about the 3D figures, that is cuboids and cubes. What is a cuboid? Actually, cuboid is a solid or a three-dimensional object which is bounded by 6 rectangular faces. Like we have, see here this is a cuboid. Here we find 6 rectangular faces. This is 1, 2, 3, 4, 5 and 6. There are 8 corners. 1, 2, 3, 4, 5, 6, 7 and 8. These are the vertices or corners. And we have 12 of the edges. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. So this is a cuboid. We have many examples of cuboids which we find in our daily life. That is like we have a book, a notebook, a room, duster, matchbox. These are all the examples of cuboids we find. See, here we have made a figure of cuboid. In this, what we are finding, as I told you, there are 6 faces. What are these faces? The first one is this A, B, C, D. The second one is E, F, G, H. E, F, G, H. Third is A, B, F, E. A, B, F, E. Fourth one is D, C, G, H. D, C, G, H. Fifth one is B, F, G, C. B, F, G, C. And the sixth one is A, E, H, D. A, E, H, D. So the total number of faces we have are 6. Then the edges. There are 12 edges. As we have seen just now, AB is one of the edge. Then we have BC, CD, DA. These are 4 edges. 4 edges at the back. EF, FG, GH and EH. 4 on these sides. This is HD, CG, AE and BF. So these are the 12 edges we have. Then we go to the vertices, the corners. These are 8. What are those? A, B, C, D, E, F, G and H. Now suppose the length of this, that is AB, is the length, that is L. BF is the breadth, that is suppose given by B. And FG is the height, that is suppose H. Now we will learn how to find out its total surface area, lateral surface area, volume and the diagonal. What is the total surface area of a cuboid? That we can see here, we are finding 6 faces. And out of these 6 faces, we are finding there are 3 in pairs. 1, 2, this is a pair of equal faces. 1, 3, 4, these are 2 equal faces. 5 and 6, these are 2 equal faces. And all are rectangular. And we know that area of rectangle is given by length into breadth. Here what we see, the front and the back, these are 2 rectangles and the dimensions of these are length and breadth. As we find, there are 3 dimensions of a cuboid. Length we have taken as L, breadth B and the height H. Then the area of this face will be L into H, because one of the edge of this is length and another is H. And we are finding these 2. So can we say that will be 2 into L into H or not? These are the two faces, the top and the base. And the dimensions of them are length and breadth. This is L and B. If we add these two, that will be twice of L into B. Then we come to these two faces. The dimensions of them are B and H. So area of each will be B into H. And hence that will be 2 into B into H. If we take 2 common, will it be L into H plus L into B plus B into H? To make it easy to remember, we write them in a sequence. We can write this as 2 into L into B plus B into H plus H into L, and that will be square unit. If the dimensions are in centimeters, this will be centimeter square, and if the dimensions are in meters, that will be square meter, and so on. So the formula has been obtained for total surface area, that is 2 into L into B plus B into H plus H into L square units. Now we are coming to the lateral surface area. Or we also say it area of 4 walls. Lateral surface area is actually the area of all the 4 faces leaving the top and the base. And why it is area of 4 walls? Because like you see in the room, if you leave the ceiling and the floor, then the area of all 4 walls will be the lateral surface area of it. And that's why we also call it area of 4 walls. So we leave the top and the base. So the base here is L into B, that is the area of base. Top is also same L into B. It means if we subtract this 2 into L into B from this one, then we find only these two. That becomes the lateral surface area of 4 walls, and that will be 2 into L into H plus 2 into B into H. If we take 2 common, we find here L plus B, H is also common into H. Do we know that 2 into L plus B is the perimeter of a rectangle? Here the length and breadth of the base are L and B, and that of top also same. It means the perimeter of this base and the top will be L plus B into 2 or not? So can we say that this can be used as perimeter of base into a height? So we can remember this as the lateral surface area in 2 different ways. One is 2 into L plus B into H, or we can also say that perimeter of base into height. Sometimes in the question you are given perimeter of a rectangular base of a cuboid is this, and the height is this, find its lateral surface area. And the student get confused. He says there is no length and breadth given. If he knows that perimeter of base into height is the lateral surface area, then directly he can multiply that and find the lateral surface area of the cuboid. Now we'll learn how to find out its volume and the diagonal. See, what is volume? Volume actually is the space occupied by any object. Here if we have a cuboid, first we have to understand the construction or formation of a cuboid. If we take some sheets like this of unit thickness, and we take many of the number of sheets and put them one above the other, like this, you see this is a book, but here we have some sheets like pages. If these pages have been put one above the other, book is formed here, and this is a cuboid. So like this, whatever the number of sheets we are putting one above the other, that becomes the height of this. And hence we can say that the space occupied by particular cuboid can be taken as the area of base into the number of sheets. So we can write this as V, that is area of base into number of sheets of unit thickness. Suppose the base is having the dimensions L and B, then the area of base will be L into B or not. And suppose we have number of sheets, they are suppose H, then the height of that cuboid will be H or not. And then we multiply it here, that becomes the volume of the cuboid. And since a unit has been multiplied 3 times, so it will be in the cubic unit. Cubic units like centimeter cube or meter cube, etc. So the formula for the volume of a cuboid becomes L into B into H, or we can say area of base into height. Area of base into height. Now the diagonal. Actually, the diagonal of a cuboid is like here AG. One of the corner of the one face joined to the corner of the other face. And if the dimensions of the cuboid are L, B and H, then the diagonal length of the diagonal like AG will be given by root of L square plus B square plus H square. Sometimes a question is asked, what is the length of the longest rod which can be kept in a box or in a room? Then we can find out that by using this formula to find out the diagonal of the cuboid or the room or the box. Now coming to the cube. Actually a cuboid only is a cube if its all the sides, all the dimensions are equal. It means all the faces are square faces. You can see here, this is a cube. These all the faces are square faces and there are 6 square faces. Suppose each side or edge of it is A. Then the total surface area will be equal to the sum of areas of 6 square faces. Sum of areas of 6 square faces. And we know the area of a square is side square. It means here we will have 6 into A square units is the total surface area. If we come to the lateral surface area, lateral surface area of this is the area of 4 walls. We say area of 4 walls. That is the area of 4 squares. It means that will be 4 into A square units. If we talk about the volume of this will be, as we say, L into B into H, it will be A into A into A, or we can say A cube, cubic units. In case we want to find out the diagonal of a cube, the formula for cuboid, it was L square plus B square plus H square. Here all the dimensions are A each. It means this will be root of A square plus A square plus A square, that is root of 3A square. Or we can say root of 3 into A. So these are the formulae of different areas and volumes of a particular cube. Now we'll take some of the examples based on these formulae based on this concept. The first example is find the lateral surface area, total surface area and volume of a cuboid which is 15 centimeter long, 12 centimeter wide and 4 centimeter high. For the solution here it is given that the length is 15 centimeter, breadth is 12 centimeter and height is 4 centimeter. They are L, B and H respectively. To find out the lateral surface area, we know the formula for lateral surface area is 2 into L plus B into H. Write the formula and they apply the values. The values are L is 15, B is 12, H is 4. This is 2 into 15 plus 12, 27 into 4. 2 into 4, 8. This is 8 into 27, 8 7 is 56, 8 2 is 16 and 5 21. This is 216 centimeters square since the units are centimeter each. The total surface area. The formula for total surface area is 2 into L into B plus B into H plus H into L. This is equal to 2 into, put the values, L into B, 15 into 12, B into H, 12 into 4, plus H into L, 4 into 15. This is equal to 2 into 15 into 12, 180, plus 12 into 4, 48, plus 15 into 4, 60. This is 2 into 180 plus 48, 228 plus 60, 288. And this comes as 2 8 just 16, 7 1, 5. 576 centimeter square is the total surface area. And then we have to find out the volume. The volume of a cuboid is given by L into B into H. Substituting the values, L is 15, B is 12 and H is 4. When we multiply, we are getting 15 4 is 60, 12 6 72, 720 centimeter cube is the volume of the cuboid. Like this we can find out the lateral surface area, total surface area and volume of a cuboid. The second example is find the length of the longest rod which can be kept in a box of dimensions 15 centimeter into 10 centimeter into 6 centimeter. We have been given here these three dimensions, means length is 15 centimeter, breadth is 10 centimeter and the height is 6 centimeter. We know the length of the longest rod which can be kept is the diagonal of the cuboid. So we can write the length of the longest rod is equal to diagonal. And we know the formula for the diagonal is root of L square plus B square plus H square. Substituting the values, we are getting L square means 15 square, B means 10 square, H means 6 square. That is equal to root of 225 plus 100 plus 36, which is equal to root of 361. And we know root of 361 is 19. So 19 centimeter is the length of the rod which can be kept in this particular box. The third example is the lateral surface area of a cube is 324 centimeters square. Find its volume. We have been given here the lateral surface area of cube, that is equal to 324 centimeters square. Now to find out the volume, we need the side. And in case the side is A, we write let the side of cube be A. Then we know the lateral surface area is equal to 4A square, and that is equal to 324. It means what will be A square? That will be 324 upon 4, which is 81. So what will be A? It means A is root of 81, which is equal to 9 centimeter. It means the side of the cube is 9 centimeter. Now after obtaining the side, we can find out the volume. We know the volume of the cube is given by A cube. A is 9, so it will be 9 cube. And we know the cube of 9, 9 into 9, 81 into 9, 729 centimeter cube. This is the volume of the cube. The fourth example is how many liters of water can be filled in a reservoir of 50 centimeter into 30 centimeter into 20 centimeter. The dimensions of the reservoir have been given here. Length L is equal to 50 centimeter. Breadth B is equal to 30 centimeter, and the height H is equal to 20 centimeter. We know to find the quantity of the water which can be filled in this, we have to find out the volume of the reservoir. We will write therefore volume of reservoir is equal to L into B into H. We know the formula of finding the volume. Substituting the values, we get 50 into 30 into 20 centimeter cube, which is equal to 5 3 is 50 into 30, that is 30,000 centimeter cube. Now we have to find out the quantity of the water in terms of liters. And we have already learnt that 1000 centimeter cube is equal to 1 liter. In the previous video we discussed this. So we can write therefore quantity of water to be filled is equal to 30,000 divided by 1000 liters, and that comes as 30 liters. It means 30 liters of water can be filled in that particular reservoir. In the next video, we will learn about the right circular cylinder, how to find out its curved surface area, total surface area and volume. Thanks for watching my video. If you have any comments or doubts, leave them in the comment box and I will get back to you.